Good afternoon. Welcome to today's highly informative webinar where we will delve into the realm of clear insights on fluorine-free foam technology. I'm Saroj Matwani, the Director of Marketing at Levitt-Safety, and I'll be your moderator for this session. The presentation will be recorded, so no need to worry about taking notes. We will email you the recording afterward. We've also allocated time at the end for your questions, which you can submit through the chat function in the dialog box on GoToWebinar. If we are unable to address your questions within the webinar timeframe, our team will personally follow up with you. Joining us today are Mike Douglas, National Segment Manager at Levitt-Safety, and Philip Novak, VP at National Foam. Without further ado, I will now pass the conversation to Mike, who will provide a brief introduction to today's topics.
Thanks, Rose. Thrilled to be here. This is a super interesting topic for me, having been around this industry for longer than I care to mention, but approximately 30 years. So welcome to everyone. Thank you for taking the time out of your day to join us. Today we're gonna be speaking about fluorine foams, but the journey of foam concentrates from proteins to what is today's SF3s is a great story, and the latest chapter of the fluorine-free concentrates in the market is a market changer, really, for the fire protection industry. I can't say I've seen anything similar. Maybe the phase out of halons that happened many years ago. Didn't tune in to hear Mike, so without further ado, let me introduce our speaker today, who's going to educate us and hopefully give us some great insights on what's going on in the industry. So it's my pleasure to introduce Philip Novak. Phil is a Vice President of Sales for National Foam. In this capacity, Phil has direct responsibility for sales, product management, training, and special projects. Phil's been associated, led, or managed all of National Foam's fluorine-free initiatives over the last several years. This includes specific portfolio foam concentrates for the oil and gas industry, municipal, industrial, aviation, and mil-spec, which is Department of Defense. Phil led the introduction of the International Civil Aviation Organization foam concentrates into Canada and advised numerous Canadian airports on the successful conversion of fluorinated aviation foams to non-fluorinated foams. He is also National Foam's Special Project Lead, dealing specifically with the Department of Defense and Naval Research Laboratory. They are the warrant holder for the U.S. mil-spec. Phil has been the primary point of contact throughout the development of National Foam's range of foams that are candidates for the NRL testing for qualification for mil-spec and commercial airports. Phil and his team have developed and presented a comprehensive foam conversion process for numerous civilian airports and stakeholders prepare to transition over to the new mil-spec foam. Phil is the past Firefighting Foam Coalition Chairman, located in Washington, D.C. I think we might have the right guy for the job, Phil. I'm going to kick it over to you and let you take it from here.
All right. Well, thank you. Thanks everyone for joining today. Let's go ahead and get. Ooh, let me move this out of the way. All right, so I kind of broke up this presentation into three groups. The first one is from a legislation standpoint in Canada, as well as parts of the US, what's taken place and what's causing the change to go to fluorine-free foams. Then we talk about the foam itself, a little bit of technology behind the difference between legacy foams and fluorine-free foams, and then the conversion process to fluorine-free foams. So a couple quick slides on us. We're a global company. We are part of Levitt-Safety International, which has been in the fire industry for over 200 years, 4 manufacturing plants around the world, and complete support in-house. So we develop our own foam concentrates, hardware, field tech service, engineering, design, and so on. And then over on the right are a host of the various trade organizations that we are involved with. UL, ULC, NFPA, Last Fire, CEN, and so on. Those are the third-party certifications. PERF is a petroleum environmental research forum. Those are the largest oil and gas companies. They're looking at the environmental footprint of the various products that they use. And then NAVSE owns the mil spec, so they actually write the specification. The FAA follows the mil spec at all the commercial airports. And sort of down at the bottom is the Strategic Environmental Research Development Program. That was funding that was put together between the U.S. Department of Defense, Environmental Protection Agency, and Department of Environment, as far as funding and the development work for NAVSE, for the FAA on testing, research, and development of various fluorine-free foams. Okay. Just a quick slide. So we serve a variety of markets around the world. Oil and gas is probably our largest market, followed by industrial, which are basically the chemical plants around the world. Commercial aviation globally, municipalities in the US, there's over 6,000 different municipal fire departments. And then obviously the various Department of Defense agencies, as well as the Canadian National Defense. All right, get my slide to move here. There we go. So a little bit of background. So PFAS, when you say PFAS, you're actually looking, depending on whose report you look at, somewhere between 5,000 and 9,000 individual chemicals. PFOS and PFOA are the two most common that you'll hear about when you're talking about firefighting foam concentrates. PFAS were invented in the 40s. C8, which are the long chains, that's a carbon chain that bonds the various PFAS chemicals together. Those were phased out in about 2015 in the Americas. And the reason for that is they're considered bioaccumulative, biopersistent, and persistent in the environment. C6 kind of ramped up around 2015, 2016. The claims are still being investigated by the EPA, but they are considered not bioaccumulative. So should they enter the body, they go through the body relatively fast. They're not persistent in the body, but they are still persistent in the environment. However, there's a whole host of other PFAS chemicals that the industries are now concerned about. When you look at fluorine-free foams, obviously they do not contain any PFAS chemicals. And the proper term people should be using is no intentionally added PFAS chemicals, because PFAS is ubiquitous in the world. It's literally in everything. There may be trace amounts in some of the raw materials that we use. So how did this all begin? The video down on the right is the actual event, and that caused this event caused the creation of AFFF. And what happened was that there was an F4 on the flight deck of the USS Forrestal. And keep in mind the Vietnam War is when they first introduced air-to-air missiles and so on. And one of the missiles actually backfired while it was sitting on the deck, started a chain reaction when it hit the plane behind it and so on. Keep in mind all these planes were fully loaded with bombs and so on. That incident killed 134 sailors, including the entire firefighting crew on the ship itself, as well as injuring 161 sailors. So the US Congress mandated the Navy to come out with a new foam, and keep in mind until this point everything was a protein-based foam, a new foam that would do a much better job for the type of weapons that the military were now using now, the types of risks and so on. So they had three main goals. One is how quickly could they knock down and control the fire, which would allow crews to escape. Second was how to quickly knock down the fire to minimize any detonation of any types of weapons that may be on. And then the third was how quickly could it extinguish the fire. So mil-spec was born in late 1967 or so. It was actually developed by the Navy and 3M. And to this day, the mil-spec still stands. Obviously, the foam concentrates have improved from a performance standpoint over that time. And at this point in time, they are in the process of converting to fluorine-free foam. So what's really driving the change in the foam industry? And it's really three things: legislation that's taken place, The supply chain, there's a concern about will fluorosurfactants be around years from now, and then insurance companies. So first off, know that PFAS is a global concern. It's just not in the US or Canada or so on. It's been a concern for quite some time. Australia's completely phased out of PFAS. New Zealand's phased out of PFAS. Most of Europe, through ECHA, which is the equivalent to the EPA in the US, is now negotiating the time for Europe to phase out of PFAS and so on. So if you look at the US, there's about 32 states that have regulated PFAS, and it's everything from a complete ban using PFAS chemicals to just a simple notification should there be a discharge into the environment. With that, the mil-spec is anticipated to go live in August of this year. So some states which have an exception to federal laws that if the federal government requires a PFAS chemical to be used. However, once a mil-spec goes live, then there's a sunset clause where those states have a certain amount of time to get out of PFAS. Our president, the Biden administration, ran on a platform that he would basically regulate PFAS. There are a variety of bills in Congress right now on how to do that, but as of today, there is no federal legislation, only state, as far as regulating PFAS. The NDAA is the National Defense Authorization Act. This is what funds the US military. Congress has mandated that the military will no longer use PFAS chemicals for firefighting foam October 1st of 2024, except for shipboard vessels. The Environmental Protection Agency is looking at putting PFOS and PFOA under CERCLA. CERCLA is the Superfund side in the US. That is where the EPA can come in and force companies to clean up the environment where there's been a discharge. If the company does not, the EPA can actually come in and do it and charge the companies for it. Then there's global supply chain concerns. And that is that one of the largest fluorosurfactant manufacturers over in France, the fluorosurfactants that go into firefighting foams is such a small percentage of what's used out in the world. They have not committed to moving that plant or to continue to make it once the laws go into effect there. And then insurance companies throughout the US and customers are being notified, should they have a discharge, their insurance coverage will no longer cover them to clean up the environment and so on. Now, when you look at Canada, the way Canada is looking at regulating it is the Canadian Environmental Protection Act of 1999. And basically what that says in short is it protects the environment and human health and basically precautionary principles. So it allows them to change regulations to enforce pollution prevention approaches. So this seems to be the way that Canada is going to move forward right now. Back in 2022, they prohibit the use of PFAS with a couple of exceptions. First is that you can train with it or test with it as long as you contain what you put out into the environment. So you have to control anything that you put into the environment, be able to reclaim it. The second is for fuel vapors. However, you see that expires December 31st, 2025. That would be oil and gas industry, the chemical industry, and so on. And again, that expires in a couple of years. Canada has put PFAS under the toxic chemical list. It's online, you can read the draft that is coming out and so on. So just be aware that Canada is following the US and Europe and Australia, New Zealand, and so on, floor plan as far as how to eliminate PFAS in their environment. The Canadian airports were first to get out in 2019. Transport Canada came up with an 8-step process that if the airports follow this, those airports may start using fluorine-free foams. Toronto was the first one to move forward back in late 2019. Since then, we've converted the 10 largest airports to fluorine-free foam. Another way they're regulating PFAS is through drinking water. PFAS chemicals are very transportable in water. They can go hundreds of miles if they get into the aquifers, which then lead to drinking water reservoirs and so on. Right now, Canada standards in drinking water is actually quite high compared to the rest of the world. You're in parts per million. So here you see PFOA and PFOS. However, no, there's a whole host of PFAS chemicals that they are actually regulating under drinking water. In the US, there's been a guideline for the last several years of 70 parts per trillion of PFOA and PFOS. There is proposed regulation now to take that down to 4 parts per trillion, which is about 37.5 million times lower than the current standard. And there's a host of PFAS chemicals, the C6 chemicals you can see listed here on the screen, that they are also looking at regulating. If you want to know what a part per trillion is, take an American football field, which is 120 yards long, 50 yards wide, dig 43 feet deep, fill it with water and put 1 drop in. That is a part per trillion. The other thing I want to point out is measuring PFAS in foam concentrates is different than in drinking water. In foam concentrates, the lowest level we can get down to at this point in time is 20 to 25 parts per billion. In drinking water, you can get down to a couple parts per trillion. The reason behind that is that the bond is so strong of these PFAS chemicals. To measure PFAS, you have to separate the chemicals, measure them independently. And that bond is so strong, it's very hard to break that down. Drinking water, there's such few chemicals, it's very easy to see those and separate them. The mil-spec was actually published in January of this year for the US, and this is really what is driving the change faster in the US. The military, by far, is the most stringent firefighting foam specification out there in the world. Every single batch has to be tested. It's live fire tested on jet fuel as well as gasoline. It has to be Newtonian, which means that the foam concentrate flows similarly to water, very low viscosity. 2 new things they've put in is a Navy HHA, which is a human health assessment. That is a standard the Navy has to how chemicals will interact with the body to ensure that using them is safe. The Army has the environmental standard, and that's if the chemical gets onto the ground, how quickly does it break down? How does it interact with various chemicals in the ground? So these are 2 brand new standards that the previous mil-spec did not have. Because it's impossible to measure 1 part per billion in foam concentrate, which is what the US Congress mandated, there's only 40 PFAS chemicals at this point in time that can actually be measured. So the mil-spec standard is that those 40 cannot be detected. The manufacturer under penalty of law has to certify there is no intentionally added PFAS chemical. And this is what's interesting. The mil-spec is a 3% foam concentrate. It has to put out the same fire at half strength, so at 1.5%, at full strength at 3%, and at double strength 6%. So there's a built-in safety factor of the firefighting foam itself. And fluorine-free foams are not compatible. And if none of this has convinced you, it's coming to an end. 3M, who basically invented this industry, a multi-billion-dollar industry over 6 decades ago, has said they are going to exit this market. They are by far the largest player in it. And they have said by the end of 2025, they will no longer be manufacturing PFAS chemicals. So let's talk about the foam chemistry for a few minutes here. All right, so we all know water does not work on chemical fires. Why? Because the chemicals float on top of water. So if you look down at the bottom left, the legacy foams, the bubbles are designed to break down quickly. And the reason behind that is that replenishes the film that forms on top of the fuel source. The film is what actually stops the vapors from coming up. As we all know, vapors are what burn, it's not the liquid itself. So if you stop the vapors, you stop the fire. The foam acts as a cooling agent. Know that only the film forms on hydrocarbons. It does not form on polar solvents. Then if you look over to the right, fluorine-free foams, it's strictly the bubbles. The bubbles are what stop the vapors from coming up. It also cools down the fire and so on. So the bubble structure, how the bubbles are made, what the outer law of the bubble skin is what's extremely important. So when you look at legacy foams, there are only 3 suppliers of the fluoro surfactants, Chemours, Chemguard, and Dynex. That is the backbone chemistry. So if you are to buy a legacy foam from what I would call a reputable supplier, they're interchangeable because there's a backbone chemistry. We all use the same thing. The only difference between manufacturer A, B, and C is how you load it. So in the legacy foam, there's water, fluorosurfactants, solvents, polymers. It's what percentage of each you put in. So there's a variety of foams out there. It's just the loading difference between the manufacturers. When you get to fluorine-free foam, there is no backbone chemistry. There literally are hundreds of foam concentrates out in the marketplace. So know that, number one, just because everyone's calling it fluorine-free doesn't mean there's chemicals of high concern. We put our foam concentrates through the green screen process. So what they do is they look at the foam chemistry, compare it to the Environmental Protection Agency's 2,000 chemicals of high concern to make sure none of those are there. So there's siloxanes that could be added, chlorines, 1,4-dioxanes, and so on. These are all chemicals that may be phased out down the road from now. So again, look at, don't be convinced just because someone's saying fluorine-free foam, there aren't chemicals of high concern. Secondly, make sure that the manufacturer, the foam you're looking at, has third-party testing to support any claims. So that's where UL, FM, EN, and so on come in. So let's look at the bubble technology for just a second. If you look over on the left, that's a typical AFFF. And again, because the PFAS bonds are so strong, right? That's what forms the film. And if you think of the original AFFF, which used 3M, that was based on Scotchgard. Scotchgard is what your mother or grandmother used to spray on clothing, spray on the sofa, and so on. So should you have a spill, it rolls off. But that bond is so strong, that's why it creates a film. It's used in women's makeup, it's used in paints, it's used in inks, and so on. When you get over to the right side here to fluorine-free foams, it's basically the lamella is what's called is the outside film of the bubble. You want those to be able to stick together, to stay together when they're on top of chemicals to stop the vapors from coming up. That is the key. So I'm going to show you here is a video. This is a fluorosurfactant. It's colored green, and the video is probably a little jumpy on your side, but you're going to see how quickly, once it gets into the fuel, it spreads. That is how quickly fluorosurfactants spread. That is the film that stops the vapors from coming up and so on. Now this is fluorine-free foam, so obviously the bubbles are magnified here, but you're going to see a yellow substance come in when I click play here. That's gasoline. So what you're looking at is you don't want the bubbles to be disturbed, or should they burst, to quickly cover it up and so on. So you can see a couple small bubbles burst there, and quickly they got back together again. Over on the right here is another fluorine-free foam you can buy in the US. And you can see when the gasoline comes in, it absolutely destroys the bubbles. You'll see them pop. You'll see that they don't quickly get back together. You'll see there's gaps and so on in it. So this is where I basically talk about how important the lamella, or the skin of the bubble, is important to the success of fluorine-free foams. When you get to polar solvents, right, so esters, ketones, alcohols, and so on, fluorine-free foams work the exact same way that AFFF works, the legacy foam work. And that is that once the bubbles get on, it forms a polymeric raft. You can see the picture over here on the left. I'll show you a video in just a second. But that is what stops the vapors from coming up. So why do we not use AFFF on polar solvents? So this right here is a polar solvent, but it's an AFFF foam concentrate. So we're going to put the bubbles on top of it, and you're going to see what happens. So you see the bubbles are just instantly destroyed by the polar solvent. It's actually just alcohol. Whoops, sorry. Let me go back one. Over here is an AFFF, and I'll speed this up just a little. So when the bubbles come on, they're there, but they start to dry out, and that's what creates the raft. I will speed this up just a second. It takes a few minutes, but you're actually going to see, we're going to pick up the raft here in just a second. So that is the polymeric raft. That is what stops the vapors from coming up on polar solvents. So that's the difference between a AFFF and an AFFF. So one of the things to be concerned about, and the rumors out there, is the viscosity. So on the left is a typical AR, so it's C6. Next is our universal green, and then two competitors you can get in the US. So what you're looking at is the viscosity, how quickly it's pouring. You want the viscosity similar, especially if you're in a fixed system and so on, so that the foam performs the same in the equipment that you currently have. So no, viscosity is a concern, and that's one of the things you should be looking at. And I'll actually speed this up a little. You can see the one at the very end is extremely viscous, similar to that of ketchup, even shaking it. And then, as I said, it's the bubble structure itself. And so this is what's called the drain time test. So when this 25% of the bubbles drain, so what you're looking at down at the bottom, the yellow there, that is basically the bubbles breaking down, creating the water and so on. So in fluorine-free foams, the bubbles generally will last hours. And why is that? Because that's what stops the vapors from coming up, right? Where in legacy foams, they're designed to break down quickly because you want that film. So I'm going to speed this up. You're at about 13 minutes now. You can see the clock. You're at 15 minutes now, and that's probably has failed or exceeded the 25% drain time. I'll speed this up a bit. You're at 35 minutes here. You can see ours on the left. The bubble structure is still quite good. A little over an hour here, and you're just about approaching the time where you're about 25% drain time. So again, bubble structure is key, how quickly it breaks down, which means that you don't have to reapply it as often if you're at a tank fire, something like that. So one of the things to know, fluorine-free foams are not compatible. So in storage, the foam concentrate, you cannot mix different suppliers' fluorine-free foam. However, if you are going to an event, a fire, you are free to shoot C8 legacy foam, C6 legacy foam, fluorine-free foams from different suppliers, all onto the fire at the same time from different discharge devices. So foam concentrates do not mix, bubbles to bubbles, it doesn't matter when you're at a fire. So let's talk about our foam and the different testing we've gone through. Last fire, UL, ULC, FM, PN, and so on, these are the standards. Know that the testing, there is no difference in testing, the certification process between legacy foam concentrates and fluorine-free. They are the exact same. So our universal green is kind of our flagship product that we use in the oil and gas industry and the chemical industry. It is UL and ULC listed, last fire, the highest level, and green screen certified, and so on, both for type 2 and type 3 type discharges, as well as freshwater, brackish water, and seawater. And there was quite a few blind tests done by the last fire group with the various oil and gas companies, chemical companies. This was actually over in Vernon, France at the Jessup facility, which is an old closed down P66 refinery. This is the largest tank. It is about 30 feet up in the air. It's 33 feet wide, so about 1,000 square feet. Premium gasoline was used. The application density was 0.16, which is the NFPA standard. Type 3 direct, less than 30 gallons to extinguish it. With the non-aspirated, a little less than 50 gallons. With the monitor, with the foam chamber, this is where 100% of the foam gets in, so you don't have to worry from a monitor where you're shooting it, wind blowing it off, or undershooting it, and so on. So it's put in at a 0.1 gallon per minute, because as I said, 100% of the foam goes onto the fuel surface itself. So extinguish less than 5 minutes, less than 16 gallons of foam concentrate itself. So from a last fire standpoint, we got the highest rating, which is good, good, and good in freshwater and seawater, and semi-aspirated, as well as aspirated systems, and so on. Now, one of the things that took place, the oil and gas companies, what their concern was, when they go to a tank fire, the tank has been burning for hours and hours and hours before you can get the pumps there, the monitors there, the crews there to actually start putting it out. So there's what is called the Border Texas test. And this is a smaller tank, but what they did down at the bottom left here, there's temperature probes that they went all the way down to the bottom. And what they're concerned about, this is in crude oil, is that on every tank fire, Every tank, there is water down at the bottom. And what happens when the water gets so hot it creates steam? Well, it's called a boil over. Basically, the fire grows to 10 times its size, which is how other tanks start on fire. So what they wanted to do, they put 6 feet of crude oil in. They put a pre-burn at 30 minutes because that got the temperature down to the water level just before the boil over level. And so that is when they started to apply the foam at 60% of the NFPA standards. And the various foams, several of them at least, extinguish a fire in less than 6 minutes. So as far as the oil and gas industry is concerned, they were convinced that fluorine-free foams would handle their worst hazard. So when you look at the various products out in the marketplace, and you go down the left-hand side, those are the various third-party tests that you can perform in the US. You see Universal Green there, it is green screen certified, and then the various tests that we have performed. So we've performed all the third-party tests that we can using Universal Green. The next 2 columns are fluorine-free foam competitors you can purchase in the US and a limited testing that they have done with their foams. But then even over to the far right, you see the two C6 foams that are used in the US now and the limited testing that they have done. Now you really can't blame them because AFFF's been around for over 50 years. So it's gotten to the point where you really don't need to do a lot of testing. But the point is we've tested it as much as we possibly can. Now this is a video this a customer sent us. This is crude oil. We went there, but they are using a gentle application. And what that is they're gonna bounce it off, and I'll click this forward just a little bit because they do a long pre-burn. They're gonna bounce it off the pan and back and just let it slide down. They wanted to see how quickly it would put out the fire and would it work with a gentle application, which is what we recommend, regardless of the type of foam concentrate you're using. You can see how quickly it knocks the fire down. You can see the foam blanket is growing in back and is starting to flow around and so on. And you see the fire is extinguished. He'll turn it off. You'll see the foam continue to flow. Now, this next video, if you don't believe foam flows, this is again in Jessup, France. This is 150 feet long and 20 feet wide. This was again a third-party test by the Last Fire Group and the various oil and gas companies. And the concern was, does fluorine-free foam, will it really flow when we get to the 270-foot tanks and so on? Will it flow the 135 feet and so on? So this is E85. Which is a fuel they use similar to gasoline. They use E85 because it's designed not to flash over quickly. So when they're lighting it, there's no risk to the firefighter themselves. It's a long pre-burn. I'm gonna push this and you're gonna see a monitor over here on the right side. And what it's gonna do is just shoot to the right side, right into center here. And I'll fast forward this just a little. We had about 1 minute and 25 seconds here. Smoke's gonna get out of the way in just a minute. And you're going to start to see the foam blanket build here. So the foam is actually flowing both ways. And I'll speed this up a little. So you see they don't move where the monitor is shooting the foam, but that the foam is flowing. And I'll just click this. It does take a while. That it does extinguish the fire completely. Obviously, the further you get away from where the foam is, starts to struggle a bit, slow down a little bit because it is burning that outer edge of the foam blanket itself. But it does eventually put out the fire. And it's extinguished right about now. So again, a tremendous amount of testing. When you're looking at transitioning and really for fixed systems, we have done well over 300 systems in the last couple of years. So there's kind of a process we go to, things we look at and so on. So number one, obviously the fire performance of the foam concentrate that you are going to go to. And then the hazard management. What type of chemical of concern? How large could it be? Is it a fuel in depth? Is it a spill fire? Can it spread and so on? Then the application technique. Is it a type 2 or a type 3? So an indirect or direct. The location of your facility. So, for example, we did a consumer brand product, but if they have a discharge, it can get into the sewer system. So if you have a discharge, can the foam, can whatever fuel of concern you have get into the waterway by some way. The reputation of your brand with social media now, if you have a discharge, if you have a fire, it's going to be online, it's going to make the news. Once you change the foam, the training, standard operating procedures need to be looked at and perhaps revised. Destruction. You are liable to prove that when you take out your old foam concentrate, that it has been destroyed properly. Legislation, look at what's there now, but also look at what may be coming a few years from now. We have found most of the Fortune 500 companies basically went around and looked for the most strict regulation they could find, and they are converting all their plants to that regulation so that they don't have to go from a C8 to a C6 to a fluorine-free to whatever may be next. Know that system conversions potentially can be complicated. Over on the left, you're looking at a general sprinkler system, but there's various discharge devices, oscillating monitors, manual monitors, deluge systems, closed head sprinkler systems, and so on, fire trucks. So there's a variety of different systems out in the marketplace. The way we go about it is we work with you, we work with your contractor, right? We work with companies like Levitt and so on. First thing we do, well, I guess if you look at the left, every system has to be assessed separately because they're designed differently. So if you look on the left, you have outdoor storage, you have indoor chemical processing, then you have outdoor loading racks and so on. So the first thing we would do is a pre-site assessment. That's where we get on the phone with you, your contractor, your fire chief, whomever needs to be involved. And we have a spreadsheet of a host of questions we ask to better understand what's at your facility, what your risks are, what type of system you may have. Most end customers can answer maybe 15% of those questions simply because they're not foam experts. But that's fine because now we know what we need to bring when we do the site assessment. Then we physically do a site assessment where we come out and walk each system. And we do that again with your contractor, with whomever, your EH&S group and so on. And we provide a report. The reports are anywhere from 40 to 100 pages long. We photograph each component and we give you options if any changes are required to convert your system to fluorine-free foam. This is what a report looks like. As I said, they're about 40 pages long, and we present this back to you step by step, and then it's up to you as to what changes you want to make. It's all a risk type based system. We go by the NFPA standards. Know that most systems out there now don't comply with NFPA standards, and why? Well, they've probably been installed sometime in the 90s or the early 2000s. Probably the manufacturing area has changed. They may be using different chemicals. They may move some equipment around and so on, and never changed or updated the fire suppression system. That's not unusual. But we will walk through step by step, answer any questions you have when we present this out. That's where you have the time to go back, talk amongst yourselves, decide how you would like to move forward and so on. The reason why they're complex is that it's a domino effect. So when we're on site, you have the hazard. What type is it? What size is it, right? Then there's various storage tanks. Is it an atmospheric tank or is it a bladder tank, for example? Then what type of foam do you have? Is it a 1%, 3%, 6% or so on? What's the viscosity of it? Then the proportioner, is it a wide range proportioner? So you may have various zones in your facility. If one zone goes off, only so much water and foam is required, but if several zones go off, more go on, or a fixed proportioner. Then there's the discharge devices. Is it a type 2, a type 3? Is it an overhead sprinkler, and so on? And then you have the flows, the pressures, the discharge rate, discharge time, and so on. These are all NFPA standards. If you change any one thing, it affects everything else. So this is why the site assessment is so important. We go step by step. We know we're going to change the foam type to fluorine-free. The viscosity is probably different. Can we just adjust the proportioner you have, or does it need to be replaced? Or can we get enough pressure out of your system to properly create the bubbles that are required? And so this is kind of the roadmap for the conversion. I won't go through all of this, but as the end user, first thing you have to do is decide what foam you're going to use, because that decides what changes need to come to the fixed system. When your system goes down for the conversion, you have to have fire cover, even if your facility is shut down for that week and so on. So do you have mutual aid? Can it be the local fire department and so on? Decontamination specialist, right? You have to take the old foam out, you have to contain it, you have to remove it, you have to destroy it properly. A local contractor in the US and I believe in Canada, each province, they have to be licensed to do that sort of work there. And then some customers require a licensed third-party engineering house should any design changes need to take place, so the drawings and so on. From that, we can put the budget together and the timeline together. Know that there has to be a plan around remediation. The number one question we get is how clean is clean? How clean do I need to make my system? There is no regulation around that now anywhere that we can find. The federal government isn't even looking at it at this point in time. The military is simply doing a single wash and so on. That's up to you. Again, you have to identify the foam, get with the foam contractor. Draining a bladder tank or a tank can take quite some time. So again, there's a whole timeline, removal process, proof of end of life of the product you remove that has to take place. And again, we work with you the entire way. So this just kind of shows everything from the design, the engineering, the pre-site assessment. We work with you, your EH&S group, your in-house design if you have that, your fire chief, third-party contractors. Go through the assessment with you, the flows of calcs if those need to change, any type of supporting drawing. If you have a chemical that we have not tested or don't have listed or so on, some of the chemical companies we worked with, they requested that for every chemical they have, we conduct in-house a UL test that they witnessed or had a third-party witness to ensure that it suppressed the fire and that this was the documentation they used for the local AHJ, authority having jurisdiction, that they made the change to maintain their operating license. And again, we have weekly meetings once this process starts to make sure that the process stays on time. So questions I get, do fluorine-free foams work? Yes, same third-party certification process listings. Are fluorine-free foams a drop-in replacement? No, but they can be made to work as effective. Will they work in my existing fixed system? Yes, with the proper conversion process. Have any facilities converted? Yes. DuPont, we did them globally. That finished up about 2 years ago. LyondellBasell, Shell, we are doing globally, 160 sites around the world. Buckeye, ADM, Exxon, just a host of various companies have already converted to fluorine-free foam. And that is all I have. I will open it up to questions at this point. Mike, if you have any questions that came in via the chat or so on, I will be glad to answer them.
Yeah, thanks, Phil. That was super. That was super interesting. A few questions, I guess, and just you were just talking about changing out, you know, from legacy foams to a fluorine-free. So what I heard was you obviously have to remove the concentrate, and you're responsible to get rid of it safely, environmentally, the right way. But I think I also heard that you may have to flush your system of any residue. Is that correct?
Well, okay, so that comes down to how clean is clean. We have seen most companies in a fixed system with the bladder tank simply remove and replace the bladder. Some have opted to flush their systems, most have not. Again, you have the end customer has to decide on what level of cleanliness they want to get to. Know that with the technology today, regardless of what you do, you will not remove all the PFAS content in your system if there's been a discharge. The military here has spent a lot of time. There's what's called a rebound. So if you use any of these third parties that are using solvents and so on to try to remove the PFAS, soon as they're done and they take a measure in the water that comes out, it's quite low, but there's a bounce back 6-12 weeks later where it gets up to about as high as it previously was.
Okay. So if a customer changes out their foam and they decide that they want to, you know, flush it out a little bit, whether they do it once through the system or more, that residue is also probably has to be cared for in an environmentally friendly way too. Is that correct?
Yes, that is 100% correct.
Yep, more questions here, sorry. Is it recommended, Phil, that if a legacy fixed system has experienced a discharge of AFFF foam, the entire system should be replaced as it's considered contaminated?
So again, that is up to the end customer. With all the systems we have done, we have not done that at all yet.
Okay.
Now, no, in the fire industry, some of the piping, the inside of the piping is actually coated with PFAS to minimize friction loss. You know, one of the things people talk about getting rid of PFAS, your 5G phone would not work without PFAS. That helps the friction loss of the electronic signals going through and so on. So again, that's up to the end customer, but in our experience, we have not seen that yet.
Okay. I have another question here regarding the competitors that you used in your presentation, your examples. I guess the question is, are they all North American manufacturers?
They're all three are global manufacturers, so they're like us. They have various sites around the world.
Okay.
But for Canada, they most likely would make those in the U.S. That is correct.
Okay. Freezing point for SFFs?
Same as AFFF. So that's it's a UL standard. So I think you'll see them all listed at 35F. I believe ours actually freezes at 23F, but UL has different ratings. So you know, I think it goes 35 down to 20, and if you're not at 20, then you have to stay at 35 regardless of what it is. Okay. But you know, if you can run water, you can run foam, right? So from a storage standpoint, the UL is 35F, but ours specifically, I believe it's 23F. It's on the data sheet.
Okay, so nothing really changes from legacy to fluorine-free foams
no, they're listed the exact same way.
Okay. Question on wetting agents and the difference between fluorine-free and wetting agents. Is that an easy explanation or not?
So wetting agents are not foam, and they are a completely different UL standard versus firefighting foam. They do not work on polar solvents, and they require a tremendous amount of product to put out the same fire that a foam concentrate would. Okay. So night and day difference.
All right. And emulsifiers, can you speak to, is that a wetting agent or is that against some other animal?
That is a wetting agent also.
Okay.
Yes. Yes. Yeah. And the military looked at wetting agents, emulsifiers, and so on for the mil spec, and none of them passed the basic gasoline test.
Okay. I got a question here. NFPA 11 requires a low expansion foam system to be calculated at 0.16 gallons per square foot using AFFF foam. Will this density be sufficient for SF3 foams as well?
So yes and no. Basically, it really depends on the fuel source itself, how large it is, what's the fuel of concern, and then basically the pressures that your system can get to, because the pressure bouncing off the deflector is what really creates the foam bubble and so on. And this is where the site assessment comes in.
Okay.
Now, I will tell you, with some chemicals, we have found that it's better to go in at 6% than what would be required to update your system. Basically, it was much cheaper, more effective to use more foam at a higher rate than to basically redesign the entire existing foam system.
Part of the presentation was really, there's a heavy concentration on mil spec. Can you further expand on that concept? I mean, it comes out of the military. I think we saw that point, but how important is it, and who is it really important to? And is it, you know, the local fire department, is it important to them?
Well, no. I mean, so mil spec is really designed around hydrocarbons, right? So jet fuel and gasoline. That's it. They don't even look at polar solvents. But the reason why it's important in this country and some other countries is that is the highest risk, right? You're at war, there are people shooting at you, bombs going off and so on. And that quick knockdown and quick extinguishment is important. So when they're looking at congressional laws, basically the view is if the military can do it, everyone else can do it. So that's kind of why I focused on the military, that they have conducted over 600 live fires, up to 6,000 square feet with all their existing equipment. So their goal on the new mil-spec was they don't want to change any hardware. And they want something that will work in their current systems and work as effectively, or at least very close. And that's what they've spent since 2017 working on.
So I guess that's why that viscosity, you know, the thickness or resistance to flow of the concentrate is important.
Absolutely, yes.
Okay.
So again, theirs is equal to, you know, the fluorine-free foam that the military uses is not an AR. So it's similar to just a triple F.
Gotcha. Okay. I've got a question in the chat. Where can I find UL certification for Universal Green?
It's on the UL website. Yep. So just contact Levitt. They can get a hold of the proper person, Barry, over in Canada. They get you that information.
Okay.
If you don't have the link to it, yeah.
All right. See if there's anything I'm trying to go through these. You talked about storage. You can't mix these. What happens if they get mixed? Have you guys done any testing on that?
Yeah, so actually the military's done a lot of testing, but so have we. And basically you get a gel. You have ruined the batch. It's not usable. Yeah, you get Jello.
How about shelf life on SF3s?
So basically it's good as long you're supposed to. NFPA requires an annual testing of each batch. So as long as it tests well, it does. What we all say is, you know, we expect it to last at least 10 years.
Okay. So as a purchaser, you're supposed to continue the testing process?
Yeah, so you should test your batch each year. So send it back to the manufacturer that you purchase it from. They will do the physical properties, fire tests, and so on, and you'll get a report back that it passed or did not pass.
Okay. Phil, this might be hard, but can you speak to disposing of legacy foams? How do people go about doing that? And you know,
so there are
inexpensive.
Yeah. So I mean, the most common method right now is high temperature incineration. There are companies that specialize in that. We do not, but there's like Arcadis, there's Clean Harbors, there's Safety Clean. There's a variety of companies. That's all they do, and that's who we would refer you to for that part of the conversion. So again, you want to make sure that they're licensed and that they can prove that the foam has been handled properly and destroyed properly.
And from a Canadian perspective, marketplace, what is the true timeline to change out? And is it a hard rule? Like, is it a must?
No, but it is coming. I know we're just talking to the Canadian Defense Group and so on. It is not yet, but you saw I put in there that you have until December 2025, right now. But Canada is about 5 years behind the US. So I assure you it is coming. And if the Canadian government doesn't do it, we're not going to be able to supply the product in a couple of years anyway. Right now, us as well as our competitors have probably phased out half of their legacy lines.
Okay.
And it's going to go away from the manufacturer's standpoint.
Is that's that supply chain raw material perspective
Yes.
you're speaking to?
And from a legal standpoint too, right? We can only make products that we're allowed to make. So for example, if they regulate PFOS and PFOA, which a lot of states have already, we couldn't use those anyway. So for example, there's a handful of states we will not ship legacy foams into right now because of state laws. There's two in Canada, I can't remember off the top of my head which are two, but they actually have regulations in place now.
But the supply going back to COVID times, it's like supply chain seems to be, it'll be affecting legacy foam's availability, not just legislation, right? Just you won't be able to,
Yes.
you won't be able to get the raw materials, I guess.
Yeah, I mean, look, you're looking at, Fortune 100 companies that make this, and from a legality standpoint for foams, it's not that large of a market. It's less than 5% of the of PFAS that's used. So is it really worth their risk and time to continue to stay in it?
And no such issues with the SF3s moving
No.
forward. I guess it's hard to tell. You don't have a crystal ball, but
Yeah, no, well, I mean, so fluorine-free foams in general break down within 30 days in the environment. So they're biodegradable. So at this point in time, no, this is why people are moving to it.
And there's a question here about difference between ULC and FM listings. Is that something you can explain?
Yeah, so one is underwriters and the other is FM. FM insures a lot of chemical plants. So FM is actually an insurance company, and they created their own standard for their facilities. So we'll do, like for sprinklers and so on, we'll do FM listings because the FM insured plants don't recognize UL, underwriter laboratories. So for that reason, because FM is an insurance company, we do FM for sprinkler systems.
How involved? I mean, you mentioned that National's done a bunch of conversions. How involved were the company's insurance company in that process?
Well, actually, we've put on seminars for insurance companies. They are very involved. It just depends on the company, the insurance company, and so on. But insurance companies, from everything we have seen, want end customers to move to it because it minimizes any type of risks or claims that they may have.
Okay. Another question here is, like you had mentioned, end users really shouldn't be looking at any SF3s unless there's a third-party certification that goes along with it, which kind of makes sense to me. You mentioned Green Screen. Can you explain that organization a little bit, or who they are, and is there other third-party?
Yeah, so Green Screen is Clean Production Action. They basically look at chemicals that go into consumer products like drapery and carpeting and that sort of stuff. They took on foam concentrates a while back. So what they do is they look at the chemistry itself. They buy batches of the product and make sure that PFAS is below what their detectable limit is. I believe theirs is 1 part per million and so on. They compare it to the 2,000 chemicals of high concern. You can go on their website, greenscreen.org. You'll see exactly what they do and who they are.
Okay. And is there other green screens out there? Maybe not under the same name, obviously, but other people manufacturers could submit to?
I don't know any for foam concentrate at this point in time.
Okay. And for like if there's 2 organizations that have green screen certification, what's the underlying, what could be the underlying differences between concentrate A and concentrate B? Is it viscosity? Is it performance?
Yeah, so it would be physical properties and performance, yes.
Okay.
Then again, it's how do they support you in the transition, right? Do they have the tech service people that'll come? Do they have the weekly meetings, right? Do they have the process? You kind of have to look at the whole picture.
Kind of that whole project
Yes.
piece rather than just a dump and run, I guess.
Yes, sir.
Got it. I am not seeing any other questions right now in the chat, and we are about a minute from the top of the hour. So Phil, I'm gonna call it, and I'm gonna thank you very much for your time. I learned a lot, and I hope those on with us also learned a lot.
Well, I'd like to thank everyone. And again, if you have any questions, please reach out to Levitt-Safety. They know how to get a hold of us, and we will respond quickly. Thank you all very much for your time.
Saroj, are you there?
I am. Thank you, Mike. Thank you, Phil. We really appreciate this enlightening presentation today. We want to express our thank you and appreciation to everyone who also joined us. This marks the conclusion of our webinar. Remember, the recording will be sent to your email, so keep an eye out for it. And if you have any further questions or looking for more information on fluorine-free foam technology, please don't hesitate to reach out to your dedicated Levitt-Safety representative who gladly assist you in navigating this technology and making informed decisions. Have a wonderful afternoon, stay safe, and make sure to follow us on LinkedIn for the latest safety content and expertise across Canada. Thank you.
Thanks, everyone.
Thanks.